Alrighty then. I think we're back. You guys, what's going on? Name's here. Yes, I know it's been a while. We've been traveling. We're over in Utah right now. We're back at the Physics Monastery, and we wrapped up our conference last week. I'm still doing some editing stuff and things, but we're gonna go over. We're gonna do a real quick recap about what the heck went on. So we had a whole bunch of folks coming in from all over the globe and mostly North America and stuff right now. We did have some folks zooming in from even the West Coast here. It was a very interesting experience. We've attended at least a number of these so far, and this has been at least probably the most fun one so far, let's say. We had folks from all different walks of life. Myself, hey, I mean, I worked in a warehouse before this. We had a COO here at some point. We had, I don't know, different engineers, different folks from all over. May or may not have watched somebody factorize large numbers in front of me, and to an observer like me, polynomial time, more investigation required. But there does seem to be a lot of overlap going on with different ideas. And I know I saw Bill in the crowd there. Um, well, the gentleman Sebastian, who I had met through the Mystify Sci crowd, and he was over in Portugal. He came here and he shared some very interesting things. And I remember it reminded me a lot like some of the stuff that Bill had been saying there. So I do think there's a lot of overlap there. And even if folks are coming at it from different perspectives, like that is basically just working directly with constants of nature. Let's look at the data. Let's see where it goes and everything. I think Sebastian been coming at it from just his retentive nature of going, why are primes prime? What's going on here? Looking for patterns. So who knows? He been some strong claims. I've seen cursory evidence, but we're gonna set up some more tests and see what might happen. But I don't know. Again, maybe we're just a whole bunch of crazy people. Maybe this is just a complete BS. Or maybe we actually focus and direct human consciousness towards interesting, useful things. Maybe we can better figure out what the heck is going on, and we can get past a lot of the current era BS, let's say. Because ultimately, if you can reach a true post-scarcity society, if we have sustainable fusion, superconductive power transmission, and the ability to at least do symplectic transforms where I don't know people didn't need to go hungry and stuff, then I think that's going to change the a lot of that dynamic. Again, is that going to be today or tomorrow? Probably not. I would love for that to be the case. But if we could literally get ourselves going in the right direction, there's no reason the next generation can't just be on like literally a whole other level where I don't know. Maybe we can explore the heavens and do something useful. And heck, if somebody just wants to be immersed in their personal sensory pod and that's where they want to exist, hey, your body, your choice. You do you, boo. Uh, so there are a bunch of things on the board. Um, where to even begin? Let's see. Well, let's actually do a little bit of a recap. So we started off was I think I got here Saturday of last week. We got here Saturday. Picked up at the airport, had a lot of discussions with folks, and on the way back, I know Mike he brought up it's like so I may not have worked at any of these large institutions or anything, but yeah, it's if you're just at a normal job, you go around, you're like, well, that doesn't seem right. That doesn't seem right. It's like brought up a very interesting point. What the heck are our incentives? Because people always say like, follow the money, follow the money. Why? Well, because money is the it's oh God, what is it? It's a no. Oh God, I haven't done finance in so long. It is basically an exchange of value because we perceive it as value because our currency is Yeah, I won't go into the technical details of my opinions on that, but long story short, you follow money. Why? Because you need money, you need to survive and everything. So that is our current dynamic and stuff. So that I would say you could boil that down to rather than just follow the money, just follow the incentives. Because incentives can take all different forms. It's very often monetarily based. It can follow a number of other avenues as well, depending upon the individual and the particular situation. I should probably check to make sure my audio is actually coming through since I am doing a different thing over here. So let's make sure I'm not all garbled. If not, I'll switch. See. Okay, all right. We don't appear to be garbled right now. That's a good thing. All right. Let's see. Cool. No, thank you for joining Atlas. I believe that's it. All right. So, um, incentive systems. What are your let's say you're in whatever industry business, doesn't need to be physics, doesn't need to be science, just any organization run by humans like us. All right, you see something wrong, what do you do? Well, obviously you do the right thing like we're always told. You go up to your boss, you explain the situation, and I'm sure since you're doing your job and you're making more work for your boss, they're totally going to view you in a very positive light. Go through, do all these other things that will create inconveniences for all the other employees, and you're obviously going to be rewarded and not potentially on the first to go list. Good thing we humans do exactly what we say we're going to do. Uh, that's more of a socio argument there, but you look and it's like very often we do things. Why? Well, this is the thing we do. This is how we've always done it. Where's it going with that? Would be a follow-up question. Good, good. That just natural response. Living the dream. Blah blah blah. Another day in paradise. I had a nickel for every time people said that. I would have many nickels. But I digress. So if people do things in a particular way, that's cool. If things are going well and you're totally happy with it, by all means, I ain't your dad. However, if one thinks that perhaps there might be a better way to do things, perhaps a more simple way to try to figure out what may be going on. Um, Maybe nature is a little bit simpler than we think. Perhaps there's a simple set of rules at the bottom of everything that give rise to the complexity that we see. That allows people to remote view some random guy in a yellow shirt from all across the globe at near to observers like us the speed of light. Okay. Why do I say this? I'm a simple kind of man. I'm just I look at stuff doing some things. Do I claim that I know what all this stuff is and all the things that it's doing? No. But at least if I can keep in my head, we have some stuff, fields, particles, however you want to quantify or what would be the best word? Quantify or formalize whatever is actually happening. Um, that's fine. That's why one of the benefits of when Thad did his first recap there, he was going over that we have five bases. Okay. With all the hundreds of constants of nature, and that's an interesting thing because depending on who you ask, they'll be like, well, there's 18 constants of nature. Well, 26. And then you're going back and forth, back and forth, back and forth. You go on the Codad's website, they have hundreds of recommended values. Why do they have all these values? I mean, this, why those constants? These are good questions because even on Codad, it's like you'll hear quarks are fundamental. The proton and neutron are not fundamental particles. The proton we crash together at observers like us very nigh the speed of light squared. Uh, yeah, and then all these particles that seem to near instantly decay and or combine with other things form. No, those are the elementary things. All right, that's cool. But I'm just like, why? Why? Yeah, well, and don't even get me started on the neutron. The neutron, it's you get outside of an active nuclei, and after like 14 and a half minutes, it just kind of decays. Why? Don't worry, it gets even weirder when you're under the right conditions in like a stellar core or something. It will reverse beta decay. It's what the heck is that? You go from a proton to a neutron. Maybe we covered that in high school chemistry. I don't remember that. I remember the normal beta decay. I didn't know the reverse. And actually, there is also an inverse beta decay. But the whole point of that 1 minute rant was the masses of the proton, neutron, and other parameters, like it's what we believe to be its radii, or most probable radii, probably. Um, it lists them. It lists those factors. It doesn't have any of the quark stuff on there. And I'm like, that seems kind of weird. Again, I'm sure there's good reasons for that. I just don't know them. But I look at it, I'm like, all right, so we've got these entities, but they're not the primal entities we claim according to our models. Okay. But we also don't have anything from really modern particle physics there for the most part, or when I say modern particle physics, mix that and being too precise. At least stuff for the weak force coming out of CERN, like you'll see like the weak mixing angle, and that's supposedly a ratio between it's like sine squared equals yada yada yada. Basically, it's the weak mixing angle. It's a ratio between the Z and the W boson, and basically that's the current way to try to see the relationship and the mass magnitudes between them. That gets updated. That down to interesting closed form to kind of get from the Z boson to the W boson. I had that in the previous video. Um, but what I find fascinating is they have that ratio. I don't see the W, the Z boson, the Higgs boson. You have to go directly to CERN's websites and everything, and they're keeping track. You can look at the data between it for the Higgs boson going between like a little under 125 GeV up to about 126 and a half GeV, and now it's seems to be settling around 125-ish and probably a little bit on the lower half of that side. Um, so I mean, you can look at that data. It's they're freely available if you have access to the internet there. Um, but that was going over the fact that within all the different constants of nature, yes, we are bringing it all the way back around. All right. You can boil things down to five bases. And in theory, all you need something is with terms of length of time, mass. You already get that from big G or H bar. Um, and then you need a notion of temperature and charge. So basically, you need E naught, which is, oh, excuse me, epsilon naught, which is the electric constant, which is based upon the definition of the Planck charge. And then you'll need something with temperature or Boltzmann's constant um, in order to cover the things with temperature. Uh, but other than that, it's you got a notion of time, notion of length or space, you get a notion of mass, and then you just need temperature and charge. And from these five Planck bases, we can replicate all the dimensionful things within the standard model. And then basically you just need dimensionless things, such as like pi, e, the base of natural logarithms and stuff like that. So um, that's an interesting thing. And again, that was the first person I heard say this, and I'll bring this up to different folks that have gone to school for physics, and they're like, "Oh, really? Oh, that's kind of cool." So perhaps it's not a very commonly known thing. Why? Because we do things the way we do them. This is just how we always do it there. Why would we look at it from a different perspective? Hey, again, if everything is all good in the neighborhood and everything, why would you break it? Now, again, there are certain things that good physicists do, such as what I learned from Professor Sean Carroll. All good physicists set H bar equal to one. Why? Because after going back and listening to a lot of the biggest ideas lectures for like maybe the third or fourth time, often mostly just passively. Um, I remember Sean Carroll, and I cut this out for a short video. He was going over like what was it, the ultraviolet catastrophe, and how Max Planck back in the day, in a moment of desperation, allegedly is like kind of did a little bit of a clue, just like what would I have to input here to fix this? We invented what ultimately, once reduced into more symplectic form, was known as H bar or Planck's reduced constant. It was originally Planck's constant, but then you had that 2 pi cycle in there. So they're like, all right, let's just divide that by 2 pi, and then we get H bar, and that's very useful for things. Very often, colloquially, you'll have her explain, like, if you see big G, you're talking about big things. If you see H bar, you're talking about little things. It's like, maybe that may fit some correlation, but I'm not. It's because H bar is just a quantity or a quantified form of action. I don't know. These seem to be actions, or when it continues and you have an action go over a distance, you have energy, and then once that energy continues for a specific period of time, you would have power and everything. Again, the two big things that I took away from Thad's recap and just in general is all right, within our physical reality, one can parameterize things using five bases. Okay. So for a noob like me, that's very good. Why? Because five is a lot less than infinity. If it's infinity, it's like, hey, well, good luck. I'll just be here till the end of time and everything. Uh, maybe the beginning of time. Who knows? But I'm like, all right, five things. Well, there's only so many different ways you can arrange these things. You could do a certain number of solo unique permutations and arrange these things in a particular way. That happens to be 44 different ways. Or if you were to just do the factorial and do like this times this times this times this, or one, basically, if you have five things, the factorial is 120, which coincidentally happened to fall into interesting formation utilizing similar powers in 4 pi to get the 20 the unit 24 dimensional hypersphere, and also may or may not have the same density as the Leech lattice, which like string theorists are big fans of. So again, I'm not saying this is reality, but I think that there are a lot of ways to parse it, and if you could start coming across certain coincidences and or mathematical, or let's just boil down logical relationships, because that's all that math is really supposed to be. It's a formalized system of logic. When I got to school, a lot of times it's like I just go through this for the class. It's like, when will we need to do this? And it's like, unless you have a very specified thing in finance or science, you're probably not going to use it. And it's like, I mean, if we're human beings, if we're trying to quantify ourselves by our logical capacity, shouldn't we at least attempt logic? Um, Also, just for any of the folks that are math phobic, I mean, Wolfram Alpha does a lot of heavy lifting. You want to be careful. You want to be careful, but precisely what you put in, because it can trail off and just give you a whole bunch of godly gook. It just keeps on going and you have no more data there. But for at least looking and going through the basic calculations, it also keeps track of the dimensions for you. AKA, it's got training wheels for a noob like me. And you start going through and you're like, look at all these things, and God, then it becomes dangerous. And you got somebody like me who it's like, all right, let's look at the fine structure constant. Elementary charge squared over 4 pi, epsilon naught h bar c, yada, yada, all that jazz. And then you're like, well, what if I broke this into pieces? And if you ever make the mistake of looking at charge squared by itself, not related to anything else, you realize that has absolutely no dimensional interpretation according to our modern understanding. Maybe there is, but at least Wolfram Alpha has probably the largest coherent set of units in the world. I think last time Professor Wolfram said it's like over 10,000 different units. You're going through them like, I have no idea these relationships. And you're going through, you see these arbitrary numbers. A lot of them might seem the same. They might have the same exponential power, and occasionally you'll scroll through and you'll see a unit that says one. One what? One of the first things I ran into was the Planck intensity. What the heck is that? That's the maximum energy flux density. Planck flux times Planck energy. Bada boom, bada bing. Okay. All right. Because I was going through it had literally at the time, default lists like 60 different units. I just happened to get up to a particular number with combinations of different stuff and things. And I'm like, all these crazy units. It was like, I don't know, like a crab is a unit of apparently luminous intensity or something. I'm like, crabs? Wow, that's kind of cool. I thought that was just the thing that scurried it along, and most things end up kind of quote unquote evolving into, so to speak, because it used the three most common base pairs of DNA or something. I don't know. I'm not a crabologist, but okay, probably get this back on track. Let's see, where were we at? Let's see our friends in the chat. Let's see what's going on as I recaffeinate. Hey, Dan. Hmm. All right. Let's see. All right. All right. We got Jax. I think my sound is working. Let me just double check because I am trusting. Okay. All right. No, no, because I'm using the AirPods because they seem to be working and it should actually function. I'm unsure occasionally because sometimes they'll just like to pardon my French. But yes, welcome everybody. How is the thing going now? I still see the start screen. Oh, you just need to. Oh, you need to. Okay. Here's the weird thing. If you have a live stream up and it says waiting for the person and the person hits start, I think until your browser sends another ping or something like that, it won't start. I know that'll happen to me where because like I'll have it on like either my phone or something, and then like I'll get a notification somewhere else and it's like refresh. And then it comes. Yes. All right. Uh, and it's commenting. Perception is analog within the boundary, but looks quantum from outside because coupling occurs on the prime resonance harmonics. Oh, that that sounds a lot like Sebastian. Um, it might explain a lot. Pardon. All right. Yeah, yes. This is exactly what we had to do to program our VCR back in the days. I still don't know how to program a timer on a VCR. I feel like that was the boss level hack where it's like there were people that could do it. I'm sure many other people could do it. But at that time and the ease of finding a solution via quick like search on the internet, I feel like as the internet went up and that became easier, the amount of people actually recording things on VCRs kind of went down. I don't know. Hey, welcome, Rick. Yes. Uh, Rick said some very interesting, provocative things, and I guess we're gonna have to see if it holds water. But all right. Hey, Dan, listen. I'm just saying, is it even possible to buy a refrigerator nowadays without Bluetooth? Like your fridge is now judging you. Oh no. But let's get back to what we were doing. Okay. Let me go through. Okay. So that Tad had given his opening talk and Echelon had kind of come through before. And for those that may have been following Echelon basically about 20 or so years ago, he was kind of like an old school programmer, like been I think it was like Citibank or whatever. It was like running on 2 megabytes of memory, like the entire ATM network. It's like, all right, your code had to be efficient. And then we started making more and more processor, more and more memory. And we had faster CPUs, creating GPUs and everything like that. Our computers are getting so dang powerful and everything. And we got plenty of more memory. And then we have the power of open source, where you can just go out onto the internet, click, copy some code, do a little tweaking, bada boom, bada bing. You've got all your stuff. Okay. I actually was between two folks. One, my current web admin for some of my websites, and then was an old school programmer, Caddy. May God rest his soul. And I remember they were having a very passionate argument over. All I remember is one individual born and raised in the USA, the other born and raised in the UK. I'm listening to their arguments, and they're both making good arguments, and they were passionate about it. And I'm listening, and I'm like, all right, let me check Merriam-Webster's dictionary. I believe that's an American-based dictionary. I looked, I'm like, all right, at least upon the preponderance of evidence, in my opinion, it looked like my friend Optimus's definition was more accurate. And then I checked Oxford Cambridge English Dictionary, or of a UK dictionary, I believe. I looked and I'm like, oh, by the preponderance of evidence in this definition, it looks like Gabby was kind of right. And I'm like, wow, wow, because it was phrased just a little bit differently. And again, I'm inputting my personal bias there and everything. It's trying to reflect, and I don't even remember what the conversation was on, but it was just two very talented individuals that I respect and a difference of opinion. And I'm wondering if it was a cultural thing, because I look at one dictionary based upon this. It seems to be leaning this way. If you use this definition, it seems to be leaning a bit more this way. Um, but let's tie it back into what Echelon was doing. So Echelon during a lot of these days is a lot of people went in to become programmers. Why? That was a new thing, and a lot of people didn't know how to do it. So there's a premium on coding. It's heck, not even that long ago, like 5 or 6 years ago, people making a big deal. It's like, oh, you lost your job. It's okay. Just learn how to code. Learn to code. Learn to code. And people get told that, and some people did that. And now we have modern AI agents where it's like, well, if you read the whole internet and you just need a very simple base forms of instructions, if you can read the documentation, you've read, I don't know, billions of lines of code and see generally what works and everything. I'm like, hey man, even on my Unix project, it's like code assistance. Open notebook assistant GPT 4.0. Why? Because I used it. I didn't pretend like, yes, I did absolutely everything by myself. It's like, no, no, it's okay. What's better? Doing something, pretending like you did it all on your own without any of these agents' assistance, or you just give credit where credit is due. Because a lot of this stuff is like just generalized format layout, and that's one of the benefits of coding because you can just click. I mean, I click code and stuff. I look at it. My problem is I'm kind of such a noob that it's like to just read the documentation would be cool. My noobness is so immense that I don't even know really where in the documentation to look for what I need. Whereas if I use an agent based chat interface, I can basically describe what I want and go search, look, and then actually find functions, write them. Sometimes it's what I'm looking for, sometimes it's not. And then you specify, and then as you're actually playing with code, because that's one of the big things, you see what it does. You run the code, it works or it doesn't. Okay, maybe you run the code, maybe it works. It's like, oh, well, you had a particular table there. No, I need to adjust these things. And you actually start going in, adjusting it, and then seeing kind of how the quote unquote gears work, so to speak, or in this case, the Boolean logic, I think is the term. Something like that. The thing that Stephen Wolf from that was the one interesting thing to come out of his search of the computational universe, just looking for stuff. It took him, I don't know how many days or weeks, but eventually his computer returned with here's the minimal logic used in Boolean algebra. It's like six lemmas or something like that. It's like A times B equals C. It was basically like this form of logic. And then like there's a 10-page proof that he says he's like, it's incomprehensible to like any human being ever. And I think he had tried to use some of the AI agents to kind of go through and parse it. Going through and parsing it ultimately is like, yeah, I haven't had any and had any luck so far. So every once in a while I'm thinking, I'm like, and again, I'm literally just playing with the blocks that I have here. I only have so many blocks. There are people with many more fancy whirling blocks and multiple dimensions and stuff like that. Listen, like, all right. we got some building blocks. All right, we got some blank bases. These seems to be limits or boundaries of something of reality as we know it. And again, perhaps reality isn't as we know it, and there's going to be some crazy other next level. I'm not wearing that shirt today, but we will see. Um, so we've got these bases and everything. Oh yeah, we need to loop back around to echelon. So basically, if math has logic there, uh, basically echelon at one point he was basically a talented coder, and a lot of stuff just kind of started getting boring to him. It's like people like, let's go through all these libraries and everything. He was telling us these stories when he did contract work with some, let's say, large and notable companies that you may or may not enjoy viewing entertainment from. And some folks are like, no, 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 we can do this. We can do this. And he shared a particular time where at one point he was in a corporate meeting and he brought up maybe we should be writing some of our own code for this because if we're doing open source too much, it's like we kind of might hyperbolically paint ourselves into a corner, so to speak. At one point, an executive is like, we're going to do all these things. We're going to have these things embedded in the browser. We're going to be able to go back from gaming to like a movie. It's going to be excellent. And his coworkers were like, oh, see, yeah, we can innovate. Yeah, we're going to do amazing things. Long story short, Echelon got fired from that job like many others because he, he pointed out the potential flaws, which, of course, everybody is always happy to hear about. Um, Long story short is he ends up messaging somebody a few years later on LinkedIn. It's like, so how did it go with implementing those features? And the guy's like, you were totally right. Yeah, no, we it never got off the ground. And I almost suspect, because I actually did subscribe to this particular company, that their website seemed to go through several name and complete overall changes over the past few years. And I'm wondering if it had something to do with that. The, the long story short is Echelon decided he's like, all right, well, what if I just created my own library that I could do all these different things? So he was developing his library over time. And what he was trying to say is like, at least the idea of, well, what's the most efficient thing in the universe? About universe. I mean, that doesn't seem like a really great leap, though. But it's like, all right, well, what if we assume this? But that's a weird thing because apparently reality as we know it has particular rules. But in programming, you can just make up the rules. Okay, well, that's fine. Oh, I can say this is going to do this is going to do that. It's like, all right, that's fine. But is it efficient? Is it effective? Can we do something useful for it aside from perhaps some may say more trivial things? And again, that depends upon the observer. We're all different. Um, so, long story short, is Echelon had been working on a particular system to see if he could model things along the standard model. And again, we know the standard model is not the end of the line. But still, we got to balance it out a little bit. And we still got to try to have a grand unified theory, as Professor Keating would say. It's like very often we're putting the toe in front of the gut. It's quote unquote theory of everything versus you got to have the grand unified before you get the toe, because who knows what gravity is. Present company perhaps excluded. Um, all right. But and the interesting thing is going along to the actual echelon story is he started developing some stuff and he's like, oh, this is kind of cool. And then he tried to do something a little bit different with the library. It's like, all right, well, I'm trying to model a car right now, but now I need to model a boat. So all of a sudden it's like I got to things started falling apart. So I scratched the library. Kind of reminds me of was it Monty Python and the Holy Grail? It's like they said you couldn't build a tower on a swamp. Well, we did it anyway. That one sank into the swamp. So we built a second tower. That one burned down, fell over, and then sank in the swamp. But the third tower, it stood. Needless to say, Echelon went through probably, he's scrapped it multiple times, many, many times, and probably even after this previous meeting, he was scrapping it again. But ultimately, the closer he seemed to be getting to reality as we know it, his returns and his ability to compute things in a highly efficient way just seemed to skyrocket, which was an unexpected thing. He's like, all right, here's the normal thing when I send code. I'm like, oh, okay, so I got, I don't know, maybe like eight, 10 lines of code or something. It's like, all right, click. I'm like, all right, oh, that's like a line and a half of code. All right. Oh, and it reproduces all this stuff. It's like, again, I'm not a programmer, but that seems interesting there. So going back and forth, I'm like, all right, he's using a very particular system. And again, ultimately, we need a data structure because that's one of the things that I think Rick and Thad had pointed out was we got data structures. Why? We got a standard model. We got our, what is it? U1, process U2, process U3. Yes, that happens to be conveniently on the board there. But those are basically Lie algebra groups. And that is our current best formulation that's widely known about the standard model, what's going on. And as you go into it, you start begin to realize it's like there's so much stuff here. It's like I'm constantly learning. I'm like, oh, that's the electromagnetic thing. It's like, ah, that's where photons come from. No, U1 isn't just where it's the breaking of symmetry between U1 and SU2, where you end up getting a massless photon and then the three other massive gauge bosons there and everything, even though U1, you're like, ooh, electromagnetism that apparently from just mathematics itself, we get for free. Like, that's pretty cool. Or at least free according to I think it's Richard Biel's videos or something. I think I got maybe an hour and a half or 2 hours into one of the ones where he was going over like the U1 stuff, and I'm like, all right, I was following and turned it into more of a passive thing, but I'm like, up through about an hour, I'm like, I can at least go through and do most of those calculations. And if I sit here and go line by line, I'm like, okay, I'm sure I could arrange an integral or something along those lines going through. I'm like, all right, that's cool. Oh, but long story short is we have a data structure, or at least the claim is that we're now to the point where, okay, we need to put together a Lagrange. What the heck is that? A quantification of the energy of our system. That sounds freaking dang impossible. It's like, how the heck do you do that? Um, So, long story. Matrices might be magic. Okay, so let's summarize because I've been going on for God over 40 minutes and I'm supposed to be recapping, but I'm just going on tangent after tangent. But basically, we're thinking that ultimately, if you're attempting to build a data structure or a method of computing that would either be better than the general things that we're using, perhaps it might not be the most optimal because ultimately, I think you would probably need a field configuration for that. Because the whole thing is, if you build things out of matter, you can't really just block all wavelengths and stuff like that as we know it. There's going to be some sort of resonance or whatnot, if you will. But ultimately, the thought is if we can find a model to simply and coherently, the observers like us, model what the heck is going on in our world, I think we can probably figure this out, or at least get a better idea about what may or may not be going on. So, where should we go with this? Okay. So basically, if we can start to model reality as best as we know it, we should be able to do that on the computing side as well. And a lot of it just comes down to it's like, okay, what are the things we're relating? And for some reason, I'm sorry, these brackets, these really get me just because I'm like, you have a thing within a thing within a thing. And you could have a set or where this is a multi-set. This is from I think Professor Norman Wildberger, just as a way for at least in my mind to say, all right, where are we putting the boxes around things? Where are these things connected? Like there, it's maybe it's well, the same reason I like cats because I also like boxes. But again, there's different ways to view these things. So, oh, Lagrangians. Okay, so again, while working with our AI agent friends, and again, even Thad was early was like, he's like, yeah, I took this Lagrangian stuff in school and stuff, but he's like, I completely forgot all about it and everything. It's kind of like asking through chats, like, oh, you're talking about the Lagrangian. Oh, it's a matrix and everything. He's like, really? He's like, oh, I, I kind of remember this, but it's like we didn't go on the very specific things within matrices or something there, or maybe he forgot. And it's like, all right, so what if we put our whole hyperbolic partition equation into a matrix? All right. So in matrix form, you do something like this. What is this? So basically, if you do the whole 1 over x plus x cubed divided by 2 pi equals I to the I raised to the negative 4 pi divided by 8, I think is the current notation. Subtract out the Planck mass and then divide by kilograms to make it dimensionally coherent there. Okay. So once you have that, all it really is you got a thing plus the inverse of a thing plus a volume of a thing divided by a rotation or a cycle, and then set equal to, was it like e to the minus pi or whatever, that notation there. Basically, it ends up being, I think it was like 11.79 or so. Basically, you get this number, which is basically the sum of the roots or something. And then you can set it equal to zero. So basically, this is just that whole partition equation set equal to zero. And if the first term is the fourth root. Now, again, I'd add this one in just for us to note there. Why? Because that would denote the matrix size. Oh, it's to the fourth power. I need a 4 by 4 matrix. All right, cool. All right. And then we have the third power, which is technically there's no term here. There was no third power because it isn't there. So we put in a zero down there for the matrix. And we got plus 2 pi x squared. Okay, so that 2 pi ends up having to be, I think, subtracted out because this 2 pi ends up being with an a term, which is basically the reciprocal sum of the roots. So basically, it's one of the first digits that gets out there. So this 2 pi a is actually, if you do the standard partition equation, you'll get a term that's like 79 something, basically that, oh, excuse me, 74.0 something. Uh, it is that a times 2 pi term. So it's like, wait a second. I always just wondered what these things were. The difference between this is 2 pi. I'm like, all right, seems to infer a cycle. And that cycle, that inverse A term, I'm like, well, we're going to claim there's some sort of an inversion going on. Those are the reciprocal sums of all our inverse roots being cycles. Now, again, maybe it's just all wrong. Maybe it's just all wrong. Maybe there's nothing here. But I don't know. When you got four roots of them, one being the amplitude of the fine structure constant, we claim. And then the other roots, which two of which are complex, so our ultimate outputs for a lot of calculations we might not even see. The only reason that Dad himself went back to look at any of those other roots or our quote unquote jus from our partition equation was because he's going through the data. He's like, this number looks familiar. Oh, that looks to be like J2, that number I need to get this thing to work. What is the relevance? And then he saw that you could sum the four J roots and you get a zero. Then you multiply the J roots and you get like 2 pi. And then you square all the roots and then you sum them together and you get negative 4 pi. And you're like, huh, something seems weird here. And ultimately, the claim is that's kind of, oh God, sometimes they'll use the term master equation for whatever framework you have. It's part of the rule set. I think that's probably a better way to say it. But like, okay, so we got a matrix. Apparently, this is a shift matrix, so you can kind of see it here. We got some stars and stuff. All right, so we got a bunch of zeros. We got a star, which is basically just representing minus 2 pi, that 2 pi plus that reciprocal root term, and then this. It's like, okay. I'm going to fill in a little bit to accelerate this so we can actually finish covering what the heck actually happened. Um, the long story short is I'm like, all right, so we've got our basis, a rotation of inverse bases, and then we got like a minus 2 pi and a minus 2 pi for other things. I'm like, what could those things possibly be? All right. my base gut instinct, and again, I don't know this. You have to follow the data, but at least it seems like we at least have the right puzzle pieces. Dad was like, I thought this was going to take a long time and everything. And he's like, wait, these are the things we need. We just need the roots from these equations and start plugging them in. It's like, oh, okay. So, but I'm like, all right, something a cycle. I'm like, all right, could that perhaps be a coupling to electromagnetism? I don't know. Maybe. Because if I say that, then I could say that, well, maybe that other solo 2 pi is, I don't know, a mass coupling term, perhaps something like that. Again, I'm just working with the blocks I have. Those are the two things that I kind of know that I could try to plug in there. Because I'm like, all right, you know, time and space. And even according to modern computation now, it seems like you can literally trade off time for space, which seems like a really weird thing, but computationally you can do it. And when Dan was here, he told us a story how back in the day he needed to, I think, put like a whole operating system on a computer, but he didn't really have like the storage space. So what he did is he took a file, big file. It's like concatenate, compress, concatenate, compress, concatenate, compress, and he just iterated that over a whole bunch of times. And basically, concatenate removes out the any open spaces in there, and then you're compressing it down. So he did that. He got like a whole operating system on like a 1.44 floppy disk or something like that back in the day, diskette. And then he goes home. And the crazier part is this is the amazing part is he just did, what was it? Uncompressed, recatenate, uncompressed, recate. He just reversed the cycle. He got all the information back out onto the other computer, and there were no errors. That is the astounding part right there. Because, yeah, could you just compress a random file and get it down to small, and then you unzip it and stuff? It's like, chances are, if you're doing extreme compression, you're going to just make it go crazy and you're going to have all these errors. The fact that he didn't have any errors, I'm like, I feel like right there, that is an interesting thing. Okay. Okay. Summary for that is, or at least computing and whatnot, and that's is the interesting thing with a lot of these LLMs because you seem to have a lot of physics oriented folks looking at it because, well, apparently a lot of these equations and stuff like that, it kind of look a lot like physics. So, and it's an exciting thing, and people are willing to actually invest money in it. And you also, you human incentives again. Don't necessarily follow the money, what are the incentives? I need a job. Okay. You need a job, you have a particular type of incentives there. Again, this is more of a societal thing. Oh God, that's I'm not gonna complain about any more of that right now. But okay. We'll continue. All right. As far as other talks, Jim Kelleher was out here. He flew out from California. He's got a really cool plane there, and we got to see him take back off and everything. And that thing got some oomph. And once he got in the air, it was actually really quiet, so it was nice. Uh, but we had met Jim out in Portugal with a bunch of folks up there, and he was a nice guy. He gave a presentation on just some interesting stuff about training models, AI agents, and a lot of folks. The thing about AI is people have very strong opinions about it. This is blasphemous, but it kind of reminds me about certain people's positions on religion. They can be very strong for it, very strong against it for their own particular reasons. But I'm like, I hear folks, and some folks are like, this is the biggest nothing burger in history. And other folks are like, it's leading to the singularity of us all. I'm like, okay, well, I don't know if either of those is true. I'm just gonna kind of like go and see what it is. I'm like, all right, seems to pass the Turing test. I can have a chat. It kind of seems like I'm chatting with a person, and now even for like my math outputs and stuff, it's like, yeah, totally, man. I'm like, oh my god, it's talking like me now. It's maybe that's intended. Who knows? Maybe this isn't me. Maybe I'm just some Sora bot plugin. Who knows? Oh god, I could only be that lucky. But oh, so Jim was giving a talk, and it was very interesting because all right, you need to train things on this many words and stuff. And then he kind of looked at it as like there's some data there. There's different magnitudes. I'm picking a particular magnitude. Feel free to disagree, but he's like, all right, blah, blah. This actually ends up being something similar to some brain functionality or number of neurons firing or something like that's kind of cool. And then he went into the generalized training schema for human beings. I'm like, oh God, don't worry. And he just kind of on the side lists, he's like, all right, the average human takes about 20 years to typically train. So you'll be exposed to like 500,000 words, I don't know, however many petabytes or zettabytes of data, if you have the ability to see and stuff. And going through this, and I'm like, I don't know if he's right, but I'm like, that sounds very plausible to me. And based upon my lived experience, it's like, yeah, 20 years to get up on some general things, having enough experience. I'm like, I could see that being a viable explanation for stuff. And then he ended up quantifying things for like the neural networks as and human operations per second, or that he called it iterative iterations per second. So uh, hey, I enjoy some good raspberry syrup on my high fructose pancakes or whatever. No, high fructose is supposed to be in the syrup. I apologize. I got it wrong. So Jim gave an interesting talk on that, and let's see, we iterated the other key points. Um, so our friend Sebastian from Portugal rolled in. He is a prime resonance theory. He's been posting his things. He's made some strong claims. So I'm like, all right, let me trust but verify. Okay, and I'm like, all right. He made a claim. He's like, P equals NP, and I'm like, all right, number one. That is technically one of the Millennium Prizes. Okay. Number two, that is not an expected result. For all intents and purposes, at least the smart folks I've talked to, is almost surely P does not equal NP. What the heck am I talking about? The generalized thought of it is all right, it's polynomial time versus non polynomial time. Why? I'm going the Wolfram Alpha. I can take two really big numbers, multiply them together. It'll tell me that's the answer. Okay. Now, it can quickly output an answer, but in order to show proof of it's the answer, very often we'll ask the computer to factorize it via primes, basically get its prime constituents, because primes are indivisible only, they can only be divided by themselves and one. Okay, our next successor there. Since primes are indivisible, one should be able to factorize any large number via its subsequent primes. Okay, now for small numbers, computers can do it pretty well. Once you get over like the 50th exponential power for things, at least Wolfram Alpha seems to just time out. That's again, is this a perfect test to say that two observers like us, P equals NP? No. But I'm like, all right, first test. All right, can you do something Wolfram Alpha cannot? All right. So I'll sit down next to Sebastian. It does like 10 to the 200 minus one or something like that. All right, boom. All right, less than half a second, and boom, pops up like factorization table and stuff. I'm like, okay, go to Wolfram Alpha. Thinking, thinking, times out. I'm like it said we have this many potential divisors and at least two relevant primes. Now, when I was doing like under the 50th power of things, it it would factorize and actually list out the primes. Once I got over 50 for exponential powers, it would time out. I'm like, all right, I got pro. Let me use pro computation time. So it's going to use additional resources. Thanks and thanks and things. It still times out. I'm like, okay, at least first hurdle might be a minor hurdle. Maybe it's nothing at all. And again, I didn't sit there and go through and be like, oh, Sebastian, let me make sure these things are factorized. I probably should have done that. I just cursory tests. All right, you hit a thing, and to an observer like me, that seems like polynomial time, and you factorize a really large number. Okay. Um, Wolfram Alpha cannot do what you are doing. Okay. First hurdle pass. We'll set up an additional test because I mean, well, okay, if that is true, I mean, we should be able to accelerate so many other things. I would love for it to be true, but again, trust but verify. So that was cool. We have, I think, a little bit of Sebastian's. He was here, kind of doing it a little bit more informally. We didn't actually record that part because it was more of just kind of an informal jive session. We probably have maybe 10 or 20 minutes of him up at the university, going over some of the stuff there. There does seem to be overlap. Does seem to be a lot of overlap, and he did say something about 108 being a magical number, something about its 32323 composition. So, I mean, that was kind of cool. Okay, so uh, Sebastian, and I'm trying to think who else. Oh, Rick. Rick was talking about things, and we covered over some of Archimedes' law of gravity and how coincidentally, if looking at things inversely can be quite useful. Um, if anyone wants to get a little chuckle about things, just do one over big G in Wolfram Alpha, or just one over the numerical digits and stuff, and all of a sudden that 6.6 yada yada, 6.67 yada 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 looks coincidentally quite like 1.498. That's like, oh, that looks kind of close to like 2 to the 7/12. It's like that's a musical thing. That's kind of close to a perfect fifth, but not a perfect fifth. Nah, it can't be anything. It's and then you look at it and you look at how we have the gravitational calculations, and then you have dynes or the CGS centimeters, grams, seconds, and then we have the SI system standard jet metric, which uses meters, kilograms, seconds, and KS system, if you would. And the interesting thing about that is that the difference between the two of them is 3 orders of magnitude. Coincidentally, and again, you can you can argue about this, but the conventional density of water, because it's extremely good at many things, is approximately 1,000 kilograms per cubic meter. Because the kilogram was initially called what they called the gray back in the day. That rhyme was kind of funny, but it was 10 deciliters of water, or 10 by 10 centimeter, 10 by 10 centimeter, 10 by 10 by 10 centimeter cube of water. That's that was kind of interesting. I mean, I would love for that to be true, and it's really close to 1 gram per uh, cubic centimeter as well. It basically holds for about the third decimal digit, and then you could imagine that there might be, and again, I delved into this a little bit, and it's like people are like, oh, the maximum density. It's like, okay, it does go higher. Oh, okay, maybe it's about 7 significant digits. And then you'll see a compendium from more recently and back in the day. It's like, well, at a very particular temperature is literally one. Or you could just take the reference density of water because it, at least for me, redirected me directly towards specific gravity, which the density of many things here, at least on Earth, that we have measured is based upon the reference density of water. It's water is assumed to be a one, and we dunk things in. So I thought that was kind of cool. And again, we'll have to see what happens. But it's interesting when you run into different folks that were coming at not the same problem, but different problems from different angles of attack, so to speak. Um, and we all kind of seem to be going generally in the same direction. Maybe it's kind of like we're hovering a maelstrom, and maybe down the throat is what we seek or seek to avoid. I don't know. Let's see where we are. I'm sorry, I've been going for about now. Let's see our friends here. Oh yes, proms all the way, baby. Oh God. Oh, Kali. Yes, yes. I'm gonna have to do another thing upon maybe some neutron decay cosmology because in I keep certain levels of insanity for things. So it's like, all right, I try to keep things as similar to what we know and then slowly lead people off the farm, so to speak. One of the most off the farm things I have is do do we do we really need like Big Bang nucleosynthesis? Like, yeah, I'm okay with that. If we just want a hot, dense state, all the matter, antimatter we need just pop out, that's totally fine. Or what if everything is compressed to a near maximally dense state, undergoing not quite a 90-degree turn, but the smoothest, tightest, most close to a 90-degree turn smoothly around a critical point, and maybe everything just hits around the density of neutrons because you got neutrons by themselves chilling, they decay, and then we got the building blocks for all the stuff we need. Just an idea. All right. Sorry. Oh God. God, so much stuff. All right, let me go back here. The Danish comedy about object-oriented programming. It's a relational system with all concepts stemming from specific interactive coupling of a myriad of objects, boundaries, and resonance without under boundaries. And welcome, Titan. Yes, yes. Oh, it raised his hand. Oh God, this is terrible. I need to catch up. Rick, you didn't ask already, please. Stays with laser tag. Uh, Here's the thing, Jax. One of my buddies, we both had Firebirds of different types, and apparently on the old GM remotes, if there was a similar car, you could attempt to reset your thing, and it would mess with other. I don't recommend it. I'm just like, oh God, I want to be able to get into my car. Let's see. Yeah, Dan, the way Sebastian was talking about total entropy, I think it was like something like total entropy will end up being like zero or something. I might just be putting words in his mouth. Apologies, Sebastian, if I am. But I'm like, I feel like I ask things perhaps already knowing what he might say, but I'm like, sounds remind me of a lot of things of what Bill was saying. So yes, the snow on TV, that CMB or dang waterish interference, who knows? All right, let's see. Yes, hey, we've all been toxic. Okay, probably just all the microplastics we're ingesting. Again, I'm not a doctor. Let's see. Uh, okay. Banter, banter. Yes, yes, yes. So my general summary of the last Physics Monastery session with arbitrary banter, and all I know is I I learned a lot of things, and I think it's really cool, and we could be doing some very very interesting things, or at least we have the potential to. Again, it's up to each and every one of us what happens and stuff. A lot of times it may seem it's like, oh yes, oh I don't matter, blah blah blah. It's like, no, no, you do matter. It's we're all part of the same one if you decompose it enough. So it's kind of how I see things. Da, da, da. All right. God, this dance comment. Yes, we're at war, Jack's Law. Just a different one than the last one. It's a terrible statement one can make and explains a lot. And the sheer fact that I just read that, I'm like, yeah, I don't know if that's telling of me or of the current paradigm, but who knows? All right. No, it is not my creation. It was Thad and Echelon. Basically, Thad was working in Europe. He basically had enough money to survive for one last month where he was staying. And he's like, all right, I've always worried about money. I have one month to try to figure out something cool. I'm just going to dedicate all my time towards that. He did that. He found at least one of the initial forms of, I think, the hyperbolic partition equation. And then some folks he knew kind of sent him a little bit of money to survive, and yeah, no, it's. And then Echelon was like, yeah, we need a place. So they drove all around Utah, and they had picked this current place north of Salt Lake City. No, it's a nice little place here. But no, it is not my creation. I'm just happen to be one of the promoters slash client slash monk, something like that. Uh, you try to use the right words. Ah, yes, people's opinions, always somewhere between singularity and nothing burger. Yes. Singular nothing burger. Oh God. It's well, here's the thing. My only hope is I don't know. I don't know. It's when I become dust, and I'm dust. If scraps of me are ramping around on the internet, hopefully they're doing interesting things. Uh, blah, blah, blah. Yeah, 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 yeah. Yep. Rhymes are very useful. Oh God, did Fall Guys actually have a story? I thought that was literally just a meme that was going around about stuff. It looked kind of fun. I never played it. Let me see. Uh, I don't intend to make people smarter. I just want people to think. That's the big thing. It's like I've had experiences where literally folks like friends would ask me my opinion on something. Oh, this. It's like, well, since you said this, I will have a positive view. I'm like, no, don't take your word be based upon what I say. I'm a crazy person. It's just, think, does this make sense? Is it all just black and white? Are there shades of gray or blue or cartoons or something like that? I can't say. Uh, Reference density is based on the measured value. Interesting. Uh, Jack's talking about the guy that played Biff from Back to the Future. He could play a good guy in the next movie. I don't. Certain actors get typecast. George Costanza. That I forget his name. I'm sorry, but he basically got typecast as kind of like the nerdy office kind of dorky guy, kind of bumbling and stuff. I watched him on one of those crime series play one of the greatest sociopaths ever. I'm like, this dude played such an evil genius, and I'm like, it's George Costanza. But he can play it, he is a professional actor. He has range. So, all right. I'm very biased. Dad occasionally may mention that, well, maybe antimatter's on the inside. Oh, well, maybe it's like a Cadbury cream egg. It's got our delicious matter outside and our tasty nougat antimatter on the inside. Um, I, Again, I'm a simple, crazy person. I often think that um, if we were to imagine there was a slight angular momentum imparted early on and perhaps continuing to be imparted generally, um, if you had a preferred direction, so to speak, I, I mean, wouldn't that just mean we're going to have a preferred direction of quote unquote angular momentum or spin? And once you pick a dimension or direction, anything following that pattern is going to be matter. And anything that manages to come around that's not following that general pattern, we would consider antimatter. Just a thought. And again, that's on the levels of explaining what may or may not be happening. It's like you have a toy model. I can rewind back to a hot, dense state. It looks really about the size of a primordial atom. You hit go. Why? Because, well, inflation seems really complicated. Or maybe explains all those things. I don't know. I just like, all right, I'm C. Go. And I do some calculations from there, and things do seem to kind of line up well. And I don't know. I'll hear folks say things like one of those things where they said, "Well, if there was the universe, so to speak, was rotating very slowly, and then basically the Hubble constant or the Hubble tension seems to completely go away, and we might be able to explain it. Is that what's happening? I don't know. But I'm like, they said very slowly. Okay. Because ultimately, what was it? I think von Neumann or somebody, I think it was von Neumann, a long time ago for Einstein's birthday or something, like, here's a solution to your equation. And it's like, close time, like, so it's like, wait a second, you can go back in time. It's like, yeah, that seems kind of weird. But if it rotates very slowly, it's okay. Look in the paper. Just take the numbers again. I don't go through all the details in that. I'm like, all right. They say that it would be around this, it would have to rotate at this rate. Okay. So I just assume circle, take the Hubble radius or whatever radius of observable universe. I plug it in. All right. I do the calculation, and what would the outside of that circle, so to speak, have to be rotating at? It would be rotating at c, the speed of light. Now, when you said universe rotates slowly, I assumed it was less than c. Or where are they talking about? Because maybe that's a boundary thing, and I'm like, oh, this seems very. And again, I'm a noob, so I just do the calculation. I'm like, I take the numbers, assume circle, seems to be coming out around the same magnitudes, and I'm like, but but it's still going at c in order to get this, the speed of light. I don't know. I don't know. Maybe I just missing the plot, but that's every once in a while you go into these calculations. It's like, okay, yeah, cool. That's trust, verify, verify. Let's see. I did like The Big Bang Theory. We were watching that last night. Let's see. Da. All right. Yeah, yeah. Well, entropy. It's people. Here's where words matter. People very often like saying entropy always increases. Is that what was said? It's more along the lines of entropy tends to increase. Okay. Because it tends to increase does not mean it will always increase. And depending on how you actually quantify entropy, so to speak, it's an interesting thing because what happens if you were in a so-called complex system, you iterate through and it just keeps cycling. How do you define complexity? Amount of starships people have? Amount of civilizations that don't destroy themselves once they get social media? I don't know. What is the parameterization there? What are you taking for your metric? And again, we got some metrics on the board and stuff. This is how observers like us have done it. We were observers on different sizes or scales. We'd probably parameterize things a little bit differently. But just from our current accounting methods, so to speak, this seems to work pretty well. Uh, da, 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 da. Let's see. But yeah, I think that's about all we had. We're like the university has a science and rap thing. Actually, we went to a little quantum computing seminar a little while back, and what was it? We had one of the guys that I recommend from a postdoc party we had been at with one of Thad and Vanessa's former roommates. I'm like, I think I recognize her. He's like, oh yeah, yeah, yeah. No, I like your shirt. I'm like, oh yeah, yeah. We remembered each other and stuff, so I joined their Discord and stuff too. So there's a lot of folks around. It's interesting times. You never know what you can learn. Just gotta be willing to go into it with an open mind and everything. Oh, no worries, Poindexter. We're just wrapping up. And again, arbitrary things. We'll try to get these things more normalized until, well, when I fly back and everything, I think next week. Yeah. So we'll get some things on track. Should be working on my computational essay just because I realize what I'm going to do now is I'm just going to do the computational essay first, just so I can get like all my thoughts out. Because also It may have been prompted by Kurt John Mungle taking a random clip out from his interview with Jonathan Garrod, and Jonathan's like, "Yeah, I like to get all my thoughts out in my general essay and stuff like that." And I remember at, at one point he was bringing up his essay when he was in a working session with Steven and stuff. His computational essay at that point was like 110, 120 pages long. I'm like, wow, Jonathan is a beast. But basically, I'm just going to go do a computational essay on like the Higgs stuff there, doing the generalized Wolfram format because I know how to at least do that now from the summer school. We'll do that post, and then I'll take sections and then refine them in a little bit more of a drier fashion because at least for the computational essay, it's like I can explain things how I speak. Just because it's yeah, there'll be left ums and uhs and stuff like that there, including stuff like that there. But I can keep it clean. I can speak in my own terms, go through, com- continue to update, and then for submission to journals like Complex Systems or Nature or whatever, then I can go back and take it, dryify the language, make it a little bit. Well, actually, if I do a good enough job, I might not need to tweak it that much because even in the computational essays, you're not doing first person. You're saying the author of this endeavor, or we, who's using like the royal we and stuff there. So I don't know. We'll see. I think as long as the general concepts are laid out well, it should be fine. And again, maybe there's absolutely nothing there. Perhaps we will get rejected because we are so completely and utterly wrong. Now, that's one interpretation. Now, perhaps that's the case, but God, how embarrassing would it be if there was actually something there that was actually useful and fundamental that ended up getting picked up after the fact and prestigious journals rejected? God, oh, that would look terrible, wouldn't it? I'm not saying that's the case. I'm sure it's not the case. God, I mean, that would throw everybody into a hoopla, and we might have to rewrite all of science or something. God, that'd be a lot of work. If only somebody was working on it. But yes, yes, Mike, I see you there. Yes, there we go. All right. So that's about all I got. But even some folks here, I think some folks here. Oh, I meant to tell you, Bill. I get emails from some different folks now every once in a while, and was it Sandro Guerrera? I think you actually had come across his blog and were commenting. And I had meant to tell Sandro to actually reach out to you. And I think you guys have some overlap. So it give you somebody else that if you're working in the same general area, you could maybe see overlaps in something. So it's always nice to be around where people are open to seeing different ideas and coming at it from the general same perspective. Because the general concept of the physics monastery is like, all right, just be open to ideas and everything. It's like you're gonna make a bold claim, that's fine. Just show your work. We might agree with it. We might not agree with it. Don't make things worse. The general tool rules that I've come up with is don't make things worse. Just do your work. That's all. 'Cause, and again, it's like some people will use words, some people will use all this crazy mathematical notation and stuff like that. It's just be willing to explain things in the best way possible. There's also human observers like us. Some folks take in things and parse things differently. Some people are very visual. Some folks need the tightest analogy possible. Some folks literally just need to see the mathematical notation line by line or the code in and of itself. Sometimes that's what works. For me, I literally feel like a lame language model. It's like I'll get prompted with some, my mind just like shoots out like venom's tendrils in all these different directions and latches onto things, does a quick analysis and like, okay, next token could do this, could do this. This has the same meaning. This meaning could go in both different ways. Okay, what is the most entertaining thing? Occasionally, I will choose that. Not always, but hey, everybody's different. So that's all I got for right now. I'm going. finish editing different things I need to clip together over the weekend and adjust some audio here and there. So those should more or less most all be coming out next week. So other than that, hey, thank you guys for coming. Peace out, everybody. It's a wacky and wild world out there, and we'll catch you next time. Peace out.